So I was watching a video some time ago, and they were taking apart a microwave oven and pricing that appliance because honestly it's awesome. And anyways, they were competent people, and they mentioned that these things here, the synchronous motor for the plate, these things, if hand cranked on the shaft, can generate a high voltage on the output. And I was like, that's interesting. And then I tried, and in fact, it worked. But cranking these things by hand is boring, tedious, and also I snapped a tooth in the gears because they are made of plastic. Because I forced it, and I thought there must be a better way, more automated, more tidy to do this. And here is my contraption. Okay, this thing is fairly low power and not much scary, although it can still shock you. And it produces some hundreds of volts AC on the contacts at a higher frequency than mains. And yeah, I know that there are better ways of making a high voltage starting from a lower one, but this is still interesting, made from trash for free, and it's a thing more a converter after all. Okay, this thing is made with a synchronous motor from the plate of a microwave oven. It's rated for 230 volts SC, and this is kind of important because it's the highest voltage type. It says 220, 240, but that's basically it. And it's paired with a 6 volts DC motor. This type of motors that are wide are kinda torquey and kinda slow, and these are handy for a lot of applications. You can find these in like compact stereos with carousel CDs. And anyways, I took away all the gears, all the plastic gears from the synchronous motor, and kept only one plastic gear, using it as a remote gear for attaching more easy the DC motor, and obviously the magnetic rotor. Anyways, this thing is after all just a dynamo. It's basically a dynamo, but an high voltage dynamo. And it probably has a lot of turns in the stator of the synchronous motor, probably in the thousands. And it reads 12 kilo ohms on the contacts. Okay, let's try this thing. Let's read its output voltage and frequency. We are now at 8 volts DC. That is kind of the minimum for letting this thing spin because that's the magnetic on the rotor of the synchronous motor. Anyways, let's see the voltage. And we are at almost 160 volts SC and a frequency of 270 Hz. Okay, now let's try a LOAD. Let's call it LOAD. It's a neon bulb. Again at 8 volts DC. This is already above the rated voltage of the DC motor. This is 6 volts. Anyways, let's see. Yeah, obviously. Okay, now let's do the safety test, quotes on quotes. Let's see if it shocks. And we are now at 10 volts DC for the DC motor, and I don't want to go past this value because it actually shocks in that case. So let's see, it produces a voltage of almost 200 volts SC with a frequency of like 340 Hz. Let's go again to the default screen, and let's see if it shocks. My hands are wet though, and yes, it does. I can feel a strong tingle, but it's kinda manageable. Obviously, if you go past this power, you'll actually get shocked. So yeah, it's better if you don't do this. Okay, now let's try at 14 volts DC. There's already a chunk of voltage, and we have here an LED light bulb. And sorry for this jam of cables and wires, but that's just to connect the bulb. Anyways, let's see if it lights up the light bulb, but it does because I already know this. And although it's dim, it does light up. Okay, let's try now at 20 volts DC. That it's a maximum I don't want to go past because I don't want this thing to explode. Probably what could happen is that the gears grind or the brushes of the DC motor burn. Anyways, let's see the output voltage and the frequency. Let's try. Okay, more than 400 volts, and the frequency more than 800 Hz. Okay, for the final test we have here, let's call it true high voltage load. It's a 6 watts fluorescent tube. And we are again at 20 volts DC for the DC motor. Let's see. Yes, it works. If I suggest to replicate this, well, yeah, actually, yes, it's fun and easy to make and not much scary, although it can still shock you. And one thing that is maybe difficult is to pair the sprocket of the DC motor to the remote gear inside, because you have to mind a precise job, because if it's too tight, you'll probably grind the teeth of the gears. If it's too loose, you'll snap those teeth. So you have to mind that and make a precise job. And another side note, there are not only the ones that run at 115 volts AC, there's also a type apparently that runs at, if I remember correctly, 36 volts AC, and it's powered from a winding on the fan motor of the oven. So if the fan motor has 3 contacts instead of 2, 2 of those contacts go to this motor here, the synchronous motor, and acts as auto transformer, step down transformer, and it runs at a much lower voltage, so you're warned. But if you need the 230 volts one, you'll probably maybe order it online. It will cost peanuts. So thank you for having watched my video, and bye!